if you look at the interface, you see here there's a workflow. You can see what steps already have been done. I just loaded a project, and I will go with you through the different steps. You see that is the first overview. Then you have the import, the transformations, the data correction, segmentation, the finalization of the project. Down here we have information window, always showing us the information about what to do in this special step. And here you can define the target of your project. So you can see here we have a T1 MRI data set at the moment available. If you have a T2 as well, we perfectly ask you to use it because that gives a more precise FEM modeling there. Then we do all of the different segmentation, and if you like to have the FEM model, you should run the volume conductor segmentation. Otherwise, you cannot do the FEM modeling. The FEM modeling you will do then during co-registration process. Okay. So, I know that because of the resolution, normally it looks a little different. So to make things more easy, I just switch off the workflow window and switch off the information window, and we get some space. Okay. So the first thing is to load the data. As soon as you load the data, it looks like this. I'll just show you. Indexing the DICOM files. What you see here is you see everything around this, every information associated with this recording. You see the birth date, see that he was a man, he is a man, he's working for me, and number of slices, and so on. Everything which is associated with the recording. We go to next. What you now have to do, you have to find the anterior commissure and set the rotation of the brain. As I did that before, everything is stored, so I can go through that pretty fast now. Otherwise, you have to scroll a little through the EEG. Now you see, okay, why I'm doing that? Because everybody of us has an anterior and a posterior commissure. That's the only thing all of our brains have in common. And that's the fixed point of the model. So I need that exactly. So the other things can differ individually, but these things all of us have, and that's the starting point. That's why we set off here. Okay, then we have to set the most anterior point, which is in front. You can certainly adjust everything here. You can go around. That's like you used to see it from CSI or whatever. What is now the aim is to look at this one here, and there should be no more cortex to be seen. I just show you. If I go in a little, you see now cortex coming up. So I have to go out, and now the cortex is gone. Okay. So this you have to do with the anterior, posterior, superior, inferior, and left and right point. And that's it. So I have done this already, and this is already finished. And now you have to set the Nasian, which is up here, then the Indian. That's the point you know from your back, where the two saints are coming up, and there's a little hole, and there's exactly the Indian. Then you have to set some brainstem markers and to define a cutoff plane. So why the brainstem markers? The brainstem markers are pretty important because they're white matter, and we need them for the inhomogeneity correction. So this is a very unique feature of BESA. The inhomogeneity correction, you have to imagine you're lying in the scanner, the whole experiment takes time. There I recorded some slices, and the contrast values of each picture will differ. And Therefore, we do an inhomogeneity correction. We contrast all of the different contrast ratios, and then we try to get rid of that failure, this mistake, this error you have there. And what you gain a lot of precision in fact. And that's a very important thing about that. Good. If I'm prompted to say whether I want to finalize the project, I want to prepare another subject. That's quit to prepare MRI data for another subject means you go back to the first step, take the next segmentation project, and you queue them up. So you can queue up different projects by just doing these few steps, and during the night or during the lunchtime, whatever, segmentation can run. And after that step, after the steps we did now, there's no user interaction necessary until the end. And automatically everything is stored. So we know from a lot of people who just do this in the afternoon and do all of this volume conductor segmentation. This takes a little time. Then they can start it and they can go home, and the next day they arrive, everything's ready. And they can start over. So that's the point. We can here now say automatic finalization, and what now happens, everything will run. You can now easily see, you can now watch the progress of inhomogeneity correction and so on. And it is pretty interesting to see how much this inhomogeneity correction contributes to the quality of the recording. And it's a pretty fast computer, that's good. Oh. Anyway, but I will stop it because this takes around about half an hour now. This is too long. I just say cancel, and cancel this one, and I want to open the project because I have done it already. Now press modify in order to show you the different work steps which are done and what they're aiming at. Okay, now we're going through all of the steps, what we did before, all of these nasal, inferior points, and so on. Brainstem markers, cutoff plane, now the inhomogeneity correction, initialized, then different segmentations, and the final results. Okay, good. So I just go back. Let me just give a view on the workflow shortly. I just go back to the inhomogeneity correction. Okay. What you see now, you see that this looks different than before. There's a definitely difference between the gray and the white matter. You can easily see it now. And that's something which is really unique for BESA. That's the only program having this feature at the moment. And you see, the precision is really good. Oops, sorry. Yes, I just right-clicked and then you can export this picture if you like. It's no problem. Okay, on the next page, we have the scalp segmentation. You see that's the reconstruction of the scalp coming from the data. Then we have the cortex reconstruction. That's the 3D reconstruction of the real cortex. And then we have here the volume conductor segmentation. That's the 4 compartment volume outlines for the skull, skull, CSF, and the brain. And we certainly can now display all of these different results in our final window here. So, as I said, this is the finite element model of the skin of the skull. This is the skull. That's all of the bone. That's the CSF. and the brain. So you see, this man is a vampire, so don't come to our office around about midnight. And he's there. No, and that's a measuring artifact, and he's certainly not a vampire. But it was funny. First time we saw it, we said, Patrick, okay, we will not work in office as soon as it's getting dark. And you certainly can here see the different kinds of cortex reconstructions. This is now the Talairach cortex reconstruction. If I go to ACPC, just watch the size. It's stretched. You can see it here very easily. So this depends on the system which you're looking at. If you look at the ACPC or the Talairach transformation, then the results look different. Even the head looks different. Duality is something between. Okay, if you now say finish, then everything is done. It's stored automatically. It's not a problem. So you will be asked in the first step. You will be asked about the naming, and then it will directly be stored to the project where the recording is coming from. And I can show you how this looks like then. If you open the segmentation project now, this is the input recording, and you see that there are different segmentation projects. The T1 segmentation was just without the volume conductor, and the T1_2 was with the volume conductor segmentation. And you can certainly give other names if you like, it's no problem. Okay, so that's about the BESA Mri software.